Hi, Joe Cerrone.
And Al Rosen.
Welcome to CAD 117 Intermediate AutoCAD in our weekly Zoom meeting. We started our meeting a little bit late because we're running virtual open houses for engineering, manufacturing, and mechanical design courses. And so we had to push this meeting back a little bit. And we typically run another meeting back to back at 7 o'clock. So we will make a 10-minute Zoom meeting, and then we'll open things up for questions. So with that, we have a number of different things for you. We have a recording here of our Module 7, and then we have our Module 7, Lab 7. We can kind of use those words interchangeably. And it's a mechanical part. And so as we've been working through this course, we've been going through both mechanical and architectural drawings. And so in this area, we're going to work on these mechanical labs, and it's a pretty big lab. And so we will create these parts, and then we will 3D print them. And so it's a nice lab, and it's going to take a couple of weeks to finish it. And so we don't expect everybody to have this done yet. If we look at it, Module 7 will be due at the end of the month. And so we have another week before that's due. With
And
that,
we might even extend that further too.
yeah, if you need more time, you can always ask for it, but we do want to keep the course moving along as we go through it. And so if we look at the objectives, um, we kind of moved away from the isometric drawings in 7. And so these objectives for isometrics have been updated to be more towards solid modeling. Here's our PowerPoint. And so you can do isometric drawing with AutoCAD, but as we've done them and worked with them, it's sort of like working with a drafting table now. We'd like to give you some basic understanding of it, where you can draw these shapes that look like they're three-dimensional, but in reality, they're not. You can't do much with them other than to have a perspective of those drawings. And so we're kind of combining that into our 3D modeling. And so let's see what this next one is. And so with mechanical working drawings, what we're doing is we're putting together we're showing how to create an assembly, how to show somebody how something goes together. And when we work with these mechanical drawings, we want to describe how the drawings are produced, be able to create these exploded and assembly drawings with balloons, part numbers, and a parts list. And then we'll create detailed drawings of these parts. And so as we work through these different exercises, we just want to get people to understand the standards of it. And so typically, like when I work for Illinois Toolworks, we would create an assembly which would show how things go together, whether it was a packaging machine or an industrial machine. You'll have the components, you'll use center lines to show how these nuts and bolts go into the different features. And then you'll have balloons, which will relate to a bill of material. And so balloon number 1 will go and tell you it's item number 1, part number 1. It'll give you a description, and it will then tell you how many of those parts you need. And so as we go through basic drawing and assembly techniques, that would be what a working drawing should look like and what it should include. We have this toe stop assembly, and so we have these different components for it, and we started working on how to create those. The dimensions are right here in the drawing, and so you have all the measurements for that as we go through and we start to model those. You will create a dimension style for the toe stop assembly, and this is the information for that. You'll use this ASME dimension style, and so you can name it ASME. It says to name the style ASME, small radii, ASME, large radii. And then you want to be able to know how to set up things like text heights, center marks, because that's what makes the drawings look professional and complete. And so we use these standardized methods to make the drawings standard. And so we plan things out. You can create a sketch, show how everything goes together. The balloons, refer to the part numbers, etc., like we talked about. And then if you want to, this isn't required for it, but you can create the detailed drawings of the parts. And so in chapter 2, we went through orthographic projection, being able to take a front view, a top view, and a side view. And you can see these light blue lines. What they do is they project over to the features that they represent in the other views. And so that's kind of old school. That's how you did things with the drafting board. And it's still used today. You still want to be able to read and make two-dimensional drawings. Three-dimensional drawings are a lot more powerful. And so we're going to go through how to model that. And so if we kind of come back here, and then we look at the chapter 11 objectives, and this kind of goes through again, creating our working drawings. Here's our PowerPoint, learning objectives for our working drawings. And I think I was just there, so I'll go back to that. Green, when we look at lab A, this is the details of the drawing. And so this has your measurements. Same thing, just a little bigger. Here's the paper for the drawing. I typically use the B-size title blocks. And so you can open that if you need to, and you can start that up. I've already got one that's already started. So I'm going to go back to the one that I had right here. There it is. I've got viewports on, and so I can, this is kind of an example. If I type in viewports, I can go back to a single viewport. When you're in model space, it does allow you to have like 4 viewports like this left, and then you can set this up as 3D, and you can have a top view, a front view, a right side view, and an isometric view. You could set it up for 2 vertical, and you have 2 views. And so you can set these different styles up so that you can be able to navigate the 3D world. I'm going to just go back to a single view, and I'll go with this isometric view like that. Switching back over to here. Here's the tutorial files as we work with this. Part 1. And we walk you through basically how to create this drawing. And so we'll model it. We'll start with the toe stop base. Show you the construction techniques for that. And it's typically the same. We start with a 2D drawing, and then we'll extrude that or press pull it. And then we'll start to put things together. And so you can see I put those 2 components together. And then a lot of these are closed caption. This one is in D2L, so I'm not able to turn on the closed caption. A lot of times I like to put the closed caption on rather than to listen to my own voice. But again, we go through the construction techniques using a 3-point user coordinate system to be able to set our XY plane to be able to draw these different features. And it takes a little bit of time, but the best way to learn it is by watching the videos if you have questions. You can see the techniques that we have for that. So I'll stop this one. That's how to do the toe stop base. And then the second part runs you through the other components. So this is the bottom of it. And then back here, part 3. And so a lot of times, there's different techniques to be able to create these pins and things like that. And so in this example, I use a revolve. And so what I did is I created the profile of the part and then I revolved it. And then after I revolved it, I used the chamfer in the 3D workspace environment. And then I show some techniques for putting in, there's a couple of pins. And so here's how you enable that pin. And I kind of use a 2.5D approach where I'll use a top view and I'll create a construction line with a circle, and then I'll extrude it. And then I'll use like a 3D move command to push it into the part, and then I'll subtract it. And so just good detailed drawing and modeling skills as we learn how to use a CAD system. And then back to the part 4. And this is where you can go to get CAD geometry. You can go to the McMaster-Carr website and you can look up parts that you want to import into your CAD models. And so we're seeing a big uptick in online retailers, including their CAD models, because then people can use them in their design work. And you'll find this for the architectural elements as well. Your manufacturers for plumbing, things like bathroom fixtures, sinks, showers are available online. And so as you start to get better with this program, Al and I will show you where you can get content. That was content from McMaster-Carr, and what I did was I imported the SolidWorks file into AutoCAD. And so you have to actually use the import command after you download the file from McMaster-Carr. And if you have any difficulty with that, just instant message us and we'll be happy to walk you through that if you do have any questions with it. But here I go through and I import that. I orientate it. And then a lot of what I'll do is I'll make these construction lines because you want everything to be kind of lined up. And so we'll use commands like the 3D move command, 3D rotate, and we'll get things orientated in space. And then we download one of the nuts. Place things in paper space. And then our last video shows you how to detail it. So once you have the drawing laid out and assembled, this is how to use multi-leaders to be able to then create the callouts for the parts. And so we detail it here. Create balloon numbers using multi-leaders. And then we show you how to create a table. And so we'll create a table in paper space, and then we'll insert that into our drawing. You can use Excel and things like that, but it's better to use just AutoCAD for everything because then everything is using one software. If you don't have Excel, what do you do, when you have a link to an Excel file? Not that most people don't, but typically what I've seen in the engineering field has been they put the tables and things with AutoCAD. And that's it. Once you have that part completed, you'll submit that to the Dropbox. You can brand it. In other words, you can put your name on it or a logo on it so that when we 3D print it, you can have that information. You can, I can kind of go into that at another time because I've only got 8 minutes. But Al and I will start releasing some videos on how to add things like an initial or a logo to a 3D printed part. All right, so I'm getting a message that I need to kind of start to wrap things up. That's Module 7. Module 7 is due next week. It's a big project, and so if you need an extension, let us know, or if you have anything that's not working, instant message us. And with that, Al, is there anything else that I need to cover before I stop our Zoom meeting? Looks like Al might have dropped out, so it looks like I'm on my own here. I think we've got it covered. I'm going to stop the recording and I'll open things up for questions.